So two more properties of exponents, negative and zero exponents. We're going to start with a zero exponent, and it's pretty cool when you see it that a to the zero, meaning any number to the zero power, equals 1. Isn't that crazy? It seems like it should equal 0, but it doesn't, and here's why. Let's rewrite the number 1 as a power. Or as a quotient of powers, actually. So I'm going to say, let's write a to the m over a to the m. Now that equals 1, right? Because something over itself, a fraction with the same thing in the numerator and the denominator, always equals 1. But we know from our last lesson that if I want to resolve this quotient, that I can write this as a to the power of the numerator, or the exponent in the numerator, minus the exponent in the denominator. And when I do that, I get a to the m minus m, which equals 0. Isn't that cool? So I know that a to the m over a to the m equals 1. If I use the quotient of powers property, I end up with a to the 0. So a to the 0 has to equal 1. So anything to the 0 power equals 1. I just find that cooler than cool. So now let's look at negative exponents. That means I have some value, a base of a, raised to a negative m. So my exponent in this case is a negative value. What does that equal? Well, without going into great detail about why, I don't find this property very useful to explain. This is a property that's easy to do, but harder to understand, so let's just do it. Anytime you have a negative exponent, a base to a negative exponent, then you're just going to move the same thing to the denominator of a fraction and make the exponent positive. So notice that if I have a to the negative m, that's the same thing as 1 over a to the m. This one is, like I said, hard to understand, but super easy to use. If you have a negative exponent, you just plop it into the denominator and make it a positive exponent. Easy peasy. So let's write 7 to the negative 2 using only positive exponents. 7 to the negative 2 equals 1 over 7 squared, done. I could write it as 1 over 49 even, because 7 squared is easy to find, but writing it as a power with only positive exponents means just apply the negative exponent property. How about a to the minus 5 times b to the 0? Okay, we have two things going on here. One, we have a to the minus 5. That's easy enough. That just means 1 over a to the 5th times b to the 0. Anything to the 0 equals 1. Done. Equals 1 over a to the 5th. For m to the minus 1 times n cubed. Okay, we want to write these only with positive exponents. First off, remember our thought bubble. We have to think about, does the minus 1 apply to the 4? It does not. There's not a parenthesis, so I can just write 4. Now my m to the minus 1 means 1 over m to the first power times n cubed is just n cubed. There's nothing to combine it with. M and n are different bases, so I can't do anything with the exponents. And 1 and 3, can't do anything with those because the bases are different. So let's make it pretty though. Let's take our numerator is 4 times n cubed over m to the first power is just m. So this time, notice what happened back here. When I had to write a power without a negative exponent, I had to turn it into a fraction. But sometimes we want to take a fraction and turn it into a non-fraction, which means I have to go from a fraction to a negative exponent. No big deal. 1 over 25. We want to write this expression without using a fraction bar. So first off, I have to turn it into a power. of some sort. I have a couple of choices here. I could call this 1 over 25 to the first power. Let's branch this off and do it two different ways so I can show you both of them. So the first one, I could turn this into 1 over 25 to the negative 1. Oh, excuse me. That isn't what I meant. 25 to the first power. And then I can use this backward, right? If it's in the denominator with a positive power and the denominator with an exponent, just move it to the numerator and make it negative. So that would equal 25 to the negative 1. The other thing is, and I think this is what the text actually meant for us to do, was to see that 25 was the same thing as 5 squared. So 1 over 5 squared, but the same thing, I'm going to use my negative property backwards, and I'm going to turn my positive 5 squared into the denominator into a 5 to the negative 2 in the numerator. Ooh, all that's hard to say. So either way, either one of these fulfill the instructions, which was just to write the expression without a fraction bar. Let's do another one. Let's write x to the 6th over y cubed. Again, if we want to write this without a fraction bar, that means we have to turn it into a negative exponent. So x to the 6th stays in the numerator, but the y cubed is the thing I have to get rid of the fraction bar. Easy enough to do, just y to the negative 3. It's so easy to do, you just plop it through. It's like you pull it through the fraction bar and the minus just gets picked up and put into the numerator. Super easy to do. Not as easy to explain, and don't worry about that, but super easy to do. Okay, let's do another one. This one's going to be a little bit more complicated because I'm going to have to do some other properties with it. I have 3 to the 8th power times 3 to the minus 10. And we want to write this without any negative exponents. So first thing is, notice I have the same two bases. Let me refresh your memory about one of the properties. A to the m times a to the n equals a to the m plus n. So we want to use that property. The base is the same, right? A, they're both 3 in this case. So I have 3 to the m, which is 8, plus n, which is negative 10. But that's the same thing as 3 to the 8 minus 10, that's 3 to the negative 2. But we want to write this with no negative exponents, so I'm going to apply this property and write it as 1 over 3 squared. One more. 10a to the 4th divided by a to the minus 4. Okay. I have to get rid of the negative exponent, so I'm going to plop this into the numerator, right? I'm just going to move it up to the numerator and change the sign. So I have 10a to the 4th times 1 over, whoop, that's not what I have, times a to the, instead of a negative 4, it's going to become the opposite sign in the numerator, which is a positive 4. And now I can combine these. I have 10a to the 4 plus 4. Remember, you have to write it, which equals 10a to the 8th power.